Hello friends, we will cover electric flux, Gauss theorem, also application of Gauss law to calculate electric field due to point charge, due to line charge, due to a plate charge, electric field due to shell, wherein we will cover the electric field if the points are placed inside, outside and on the surface. Electric field due to a sphere of charge, similar to the shell. This will also cover field outside, inside and on the surface. Electric field due to two positive surface plates in three regions, left, right and center. Electric field due to two surfaces of oppositely charged parallel plates covering all three regions when the point is placed left, center and right. Electric flux is a property of electric field. Electric flux through a given area held inside an electric field is the measure of the total number of electric lines of force passing normally through that area. These are the electric field lines passing through the area is forming the electric flux. That means flux depends on the number of electric field lines and area. If you look at the first picture, a smaller number of electric field lines, so less flux. Stronger electric field lines are shown in the second picture, that is more crowding, therefore means more flux. So flux depends on electric field and area. So flux is equal to, this is the symbol of flux, flux is equal to E into A. Now let us look at the picture, this picture again. All the lines are crossing the surface. If this surface is tilted, then we will observe that few of the lines, electric field lines, will not pass through this surface. In fact, it will move over the surface. Therefore, flux depends on the angle. Say this angle is theta. And we can write the formula as flux is equal to E dot A cos theta. In case it is an uneven surface, that is geometrically the area formula is not known, then we will take a small part as ds and integrate the complete surface. So instead of writing A, we will take a small part if the geometrically we do not know the formula of the area. So we are going to write E dot ds cos theta. If it is again not a geometrical figure, but it is a closed area surface. See, this is a closed area surface. It makes a complete closure. So then we will add all these together, integrate to get the flux. Surface 1, surface 2, surface 3, we'll add them up, integrate them and we will get the flux. Gauss theorem. This theorem gives us relationship between the total flux passing through any closed surface and the net charge enclosed within the surface. Let us place a charge inside a cylinder as shown in the picture. According to Gauss law, the total flux linked with a closed surface is 1 by epsilon naught times the charge enclosed by closed surface. Mathematically, flux is equal to charge by permittivity of medium. What does it mean? If a charge is placed here inside a medium, so what will be the amount, what will be the flux in here? It will be the total, whatever the charge here divided by the permittivity of the medium. How much permission it is going to give, the medium is going to give. So this is the second formula that we have derived from for the flux. So first formula was E dot ds. This was also flux. Q by epsilon naught is also flux. So we can equate it and write it as Q by permittivity equals to close integral E into ds. Here the value of permittivity of material is mostly, when we are going to calculate, will be written as 8.85 into 10 to the power minus 12. For applying Gauss theorem, because in the coming up applications for a point charge, for line charge, for spherical, for the shell, we will be using these 4 rules, 4 steps continuously. So let me explain you these 4 steps that we are going to use for the application. For applying Gauss theorem, we will use these 4 steps all the times to calculate electric field. Step 1. To calculate the electric field at a point, we must consider hypothetically a Gaussian surface such that the given point is on the surface. Okay. And E is the electric field of charge that has a magnitude and direction. Q is the charge. Step 2 is to calculate E dot ds cos theta. ds is the area, small area, and cos theta is the angle between electric field and area vector. Let me explain you what is an area vector. If this is a surface, right perpendicular on top of it will be the area vector. If this is the surface, then this will be the area vector. If this is a surface, then this will be the area vector. So second step is to find out E dot ds cos theta, and the value for theta will be the angle between the electric field and area vector. Step 3 is to calculate charge inside a surface. Now charge enclosed by surface, say Q, for a point charge. Now this Q will be replaced by lambda L in case of a line charge and sigma A for a case of a plane charge. Step 4 will be to apply the Gauss theorem main formula, which is Q by epsilon naught equals to close integral electric field into area. Okay. In this slide 1, I have actually written the main 4-step rules that to apply. These are the rules that we have just discussed that will be applicable. We have written this on the right hand side so that it is for the quick reference. Okay. Electric field due to point charge. Here we are considering a point charge Q. This is a point charge Q and we want to calculate the electric field at point P here. As per Gauss theorem, 4 steps which are applicable. The first step is to consider a Gaussian surface such that the given point is on the surface ds. So we are going to create a Gaussian surface hypothetically. This is the surface that we have created. Here charge Q has radial outward electric field. What it means is it has got radially outward electric field, right? So considering at this point, this will be the electric field line. The area vector from point P will also be in this direction. So theta will be 0 because the electric field and the area vector are in the same line. That means cos 0 is equal to 1. So E dot ds cos 0. Okay. The ds will be considered as 4 pi r square, and 4 pi r square is the total surface area of this circle. Okay. Step 3 will be charge enclosed by surface is Q. Step 4 will be applying Gauss theorem formula, which is Q by epsilon naught equals to E dot ds. Now E dot ds, this part can be replaced by E dot 4 pi r square. So we are going to write E dot 4 pi r square is equal to Q by epsilon naught. Keeping E on one side and bringing rest in the denominator here, we can rewrite the formula as E equals to Q 4 pi epsilon naught r square. Okay, moving on. You can actually note down this formula in your copy. applying theorem to calculate electric field due to a line charge. Okay. See the 4 steps rule right side of the screen. These are the 4 steps. Okay. As per our first step, we have to select a Gaussian surface. For line charge, we will consider a cylinder. For a line charge, we are going to consider a cylinder here. Okay, step 2 is to calculate closed integral E dot ds. Here ds for cylinder will be in 3 parts. Bottom of the cylinder, curved surface of the cylinder and top of the cylinder. Now look at the theta for bottom and top of cylinder will be 90-degree angle. How? This is the electric field direction. And this is the direction for the area vector for the top. They are making an angle of 90-degree. Similarly, for the bottom, this is the area vector for the bottom. Along with the direction of electric field, they are making a 90-degree. So cos 90 is 0. So the top E dot ds cos 90 will be 0. E dot ds cos 90 for the bottom will also be 0. We are left with curve part, which is E dot ds cos 0. How is this 0? Because this curved surface area vector is in this direction, similar to the direction of electric field. So the theta between these two is 0. Cos 0 is 1. So E dot ds can be written as, this area can be written as 2 pi r L. Now the step 3, charge of enclosed by surface is q. So for a line, we are going to take q as lambda L. So q will be lambda L. Step 4 is applying Gauss theorem. The formula is q by epsilon naught equals to E dot ds. Here we have already found out that E dot ds is E dot 2 pi rl. We are going to replace it in the formula here. Q by epsilon naught, the value for q is lambda L by step 3. So we are going to write lambda L by epsilon naught. Keeping E on one side, we can rewrite this formula as E is equal to lambda 2 pi r epsilon naught. So you can note down this formula as well. Okay. Applying Gauss theorem to calculate electric field due to a plate charge. Step 1, as per the 4 rule written in the right side, right corner, is considering a Gaussian surface such that the given point is on the surface. So for this plate, we will be considering a horizontal cylinder. Step 2 is to calculate closed integral E dot ds. Here again for cylinder will be in 3 parts, which is bottom of the cylinder, the curved surface and the top. So these are the 2 parts and the third. Okay. So you're going to write the curve E dot ds, the top and the bottom. We are just considering this as the top and the bottom. Okay. So E dot ds cos 90 for the curve. How? This is the direction of the electric field. For this surface, this is the area vector. So this is making an angle of 90. Okay, so cos 90 is 0, so we can keep it as 0 here. Instead of writing E dot ds, we are keeping for simplification E dot area. ds represents area, so E dot ds and cos 0. Why this is 0? This is the direction of area vector for this plate. This part of the cylindric, which we can just say it is what can I say? It is the bottom. Okay, so bottom, this and electric field are in the same direction. Therefore, we can say EA. Plus again, this will be EA. So it will become 2EA. Charge of enclosed surface is Q equals to sigma A. What is sigma A? This is step 3. What is sigma A? In case of a plate, we always write charge as sigma A. Now putting the values in the step 4, applying Gauss theorem. Q by epsilon naught equals to E dot ds. E dot ds can be written as 2EA. We are not simplified area here. Like we have not opened it up into pi r square, whatever. So we are just writing 2EA. So 2EA will be written here. Instead of writing Q, we have written sigma A. So sigma A by epsilon naught A, and A will get cancelled. And we will be left with, for a plate, electric field is sigma 2 epsilon naught. So this formula we are going to use immensely in the coming up session in few minutes. So just remember, E is equal to sigma 2 epsilon naught for a plate. Now let us understand first a shell. Okay, what is a shell? Shell is a spherical body which is hollow from inside. As a result, charge always remains only on the surface. And it is empty from inside, therefore the charge inside a shell will be 0. Okay. We will be calculating the electric field on shell when we place the test charge at 3 different locations. Outside the shell. Now, this is the shell. When we are placing it outside the shell, inside the shell, and on the surface. Okay. This table, for your convenience, is divided into 3 parts for the 3 cases, or maybe we can say for the 3 situations. Situation 1 is when the test charge is placed at a distance, say small r, like it's kept here. Okay, this is the situation 1. Okay, this is where it is kept. Mean small r, it's more than the radius of the shell, and radius of the shell is indicated by the capital R, and this is where the point is kept. Here will be the situation 2, when the test charge is on the surface of the shell. If you see, if we are going to place this element, this point, this test charge all the way here, then this small r will be equal to the capital R in case it's kept here. Okay, it's kept on the surface. Okay. The test charge is placed inside the shell. This will be the third element, the third situation, when it is kept inside the shell here. Okay. Here small r is less than the capital R. For situation 1, when the test charge is placed at a distance small r, let us follow the 4-step rule written in the right side again. Now step 1 is to consider Gaussian surface such that the given point is on the surface. So we will make a concentric circle with radius r here. Just like the point charge, just like we derived it for the electric field due to a point. Okay, so we are going to have a concentric circle that is covering the point P. Step 2 is to calculate E dot ds. The ds is 4 pi r square, and which is step 3 will be charge of enclosed surface, which is Q. And then finally applying the Gauss theorem. So E is equal to E dot 4 pi r square equals to Q by E. So E will be, electric field will be equal to 1 by 4 pi epsilon naught Q by r square. This will be R in case it is kept outside. In situation 2, when the test charge is placed on the surface, that is small r is equal to the radius, which is capital R, if these two are equal. Again, we are going to follow the same, all the 4 steps here. This will be our Gaussian surface at that time. E dot ds will be 4 pi capital R square, because this will be R that time. If we have to take this formula, this R will be replaced by capital R. Charge of the enclosed surface is Q, which will remain the same. Applying the Gauss theorem, we will come to know E is equal to 1 by 4 pi epsilon naught Q R square, because R will be replaced by this R. This will be the R if it's on the surface. Okay. In this third case, the point is inside the shell. Now here we know the shell is empty. Therefore, the charge is 0 inside. That is, the value of Q is 0. So electric field will also be 0 here. So if you see the formula, E, like this part in Gaussian theorem is 0. So Q is 0, therefore E will be 0. Okay. So if we see graphically, we can represent this. This will be the electric field, which is for in case it is inside, and maximum when it is here, and again it will be declining in this form E when it is outside. Okay, in graphically you can remember this graph. Gauss theorem, electric field due to a sphere charge. Now instead of a point charge, we have taken a sphere of charge in this slide. The main difference between shell and sphere is shell is hollow from inside, whereas sphere is not empty. Shell has 0 charge inside, whereas sphere has charge. You can see this charge. Okay. So which we will calculate the value coming ahead. So just like the previous slide, we will place the test charge at 3 different locations outside the shell. That will be like here. Then on the surface of the shell and inside the shell. So this table for your convenience is divided into 3 parts for 3 situations. Okay. When the test charge is placed at a distance say small r, that is outside the sphere. This derivation is just same like point charge or shell. So the value will be equals to 1 by 4 epsilon naught q by r square. In situation 2, when the test charge is on the surface of the sphere, like it's right here. So small r is equal to capital R. So the formula only, you have to change the small r to capital R here. So E is equal to 1 by 4 pi epsilon naught q capital R square. Small r, capital R. Situation 3, test charge is placed inside a sphere. We will apply the 4-step rule for this situation so that it is more clear to us now. Okay. So is to consider first a Gaussian surface. If it's inside, the first is the Gaussian surface. The second is calculating E dot ds. Here it will be E 4 pi r square, whatever the value inside will be E 4 r square. And step 3 will be to calculate Q. Okay. Here the Q will be written as rho into volume because it has, Q will be written as rho into volume because it is not empty. Okay. The volume formula for a sphere is 4 pi r cube by 3. So it can be written as E dot 4 pi r square equals to, applying the 4th step. E dot, that is coming from here, E dot 4 pi r square equals to rho 4 pi r cube by 3. Okay. So when we do the mathematic here, then we come to know the electrical field is equal to rho r by 3 epsilon naught. So you can note down this formula. This is little different than the shell, whereas shell is E is 0 when it's inside. Let's look at the graphical representation here. This is E is proportional to R. If you see electric field inside is proportional to R. So electric field here. Okay. Here it is maximum. Then again similar like shell, it is decreasing here. So this will be E proportional to R square, 1 by R square. So E by 1 by R square. Sometimes the graphically it is being asked how do you represent it. Okay. We are just left with 2 more to cover in this. Now applying Gauss theorem to calculate electric field due to 2 positive plates. So this is one plate and this is the second plate. So we will learn by placing a test charge at 3 different locations. Left from the plate, that is if we are putting the point here, left from both the plates. Okay. Center, if we are placing it in the center of the plate, and right side of the plate. So we have learned that electric field due to a plate is, I told you we are going to use this formula, right? So E is equal to sigma to epsilon naught. So we have previously derived that. So before we start visualizing the number line, let's visualize the number line. Say from 0, if this is 0, So right side are positive and the left side will be negative, right? So you know from the zero, the number line, zero, positive and negative. Similarly, if a test charge is placed on the left side, then electric field will be negative. Okay, so here if the arrow of the electric field is showing right to left, if it's showing in this direction, which is in the number line will be negative, because suppose it's 0 here, then this will be towards the negative direction. So we are going to write E is equal to minus epsilon 2 pi 2 epsilon naught, right? Sigma minus sigma by 2 epsilon naught. Similarly, from here all the way to this point will be again the same, minus sigma 2 epsilon naught. So if we add these two up, the 2 and 2 will get cancelled and we will be left. Electric field in this area will be equal to minus sigma epsilon naught. This will be the case 1. Now, the point is in the center in case 2. Here the electric field that is pointing left to right side, therefore will be positive. So this is from, if you see the number line, suppose this is 0, this will be the positive side. So it will be E is equal to sigma 2 epsilon naught. And from this side, it's pointing towards the left side. If you can recall the number line, this will be the minus. So plus and minus, electric field in between will be, E will be equal to 0. Now this is the third case. In third case, the point to measure the electric field is on the right side of both the plates. As the vector pointing is from left to right, both the electric field will be positive. So E is equal to sigma 2 pi. E is equal to sigma 2 pi. So here the when we add them up, 2 and 2 will get cancelled and we will be left with E is equal to sigma epsilon naught. Okay. Now comes the last slide for this Gauss theorem. Okay. Now here we have two oppositely charged plates, positive and negative. So this is a plate which is a positive plate and negative plate. We need to note down following two things. One, we already know the vector point reads from left to right. Okay. And the second thing is electric field is not generated but terminated at the negative plate. So it cannot start from the negative plate, it gets terminated there. So the arrow will be reverse. Even if it's coming from the negative plate, it's going to be reverse and arrow will be pointing inwards. Okay. Now let us consider this is case 1, case 2 and case 3. Studying case 1, when the point is on the left side, we note electric field from positive plate. This is the positive plate will be, because it's coming onto the from the number line 0 to this direction, which will be E is equal to minus sigma 2 phi, correct? Sigma 2 epsilon naught. Now for the negative one, it cannot, it gets always terminated here. So it does not generate from here, it gets terminated here. So this will be the direction of the arrow. Now in this case, electric field, because the arrow is, suppose this is 0, from the number line it is in this direction, because of that, so these are it will be positive. So E will be equal to sigma 2 pi. So in this, when we add these two up, sigma 2 epsilon naught plus minus sigma 2 epsilon naught, E will be 0. This will be the case 1. Now in case 2, when we place the point in the center, okay, the electric field for the positive plate is E equals to sigma 2 epsilon naught, okay, and for the negative plate, it will always terminate here. So this will how the arrow will look like. So it will be minus sigma by 2 epsilon naught. So when we add these two up, no, actually this will be plus. So these two, sigma 2 epsilon naught and sigma 2 epsilon naught, when we add these two up, so this will become 2 and 2 will get deleted from numerator and denominator. We will have E is equal to sigma epsilon naught. In the third case, again, you can read this. So this will become, for one side it will be sigma 2 epsilon naught plus minus sigma 2 epsilon naught, and electric field will be 0. So here electric field is 0, here electric field is 0, and in the center that's the value. Whereas if the plates were both positive, then you can see in the center it was electric field was 0. Okay, I hope this was helpful to you. Thank you so much.